G'day, I'm Ian Smith, and volunteer here is getting closer to the water, so it's time to talk about spar making. I built the mast and the gaff and the boom for my 24-foot gaff sloop Volunteer before I set the frames up, because I knew that once I started I wouldn't have room to work at the spar bench. The idea of this YouTube series hadn't occurred to me at that stage, so I've only got still photos to show you. I'll show you more of these later on, but I'll show you the techniques of spar making as I build the spinnaker pole for this boat, and some footage from building the spars for Britannia years ago. I'll also show you how I shaped the bowsprit from an older spar, and I'll show you how spar making techniques are used on other items like spreaders and the tiller. Some of you have my book on wooden boat building, and you'll notice that I mentioned spar making fairly briefly there. But there's a much more thorough description in my earlier book, The Open Boat, in which I describe how I built the spars for my historical 18-footer replica Britannia. I know I'm biased, but I reckon it's one of the best spar making guides around. It comes from decades of experience of building masts and spars. I've lost count of the number I've built, but I'll mention a few of them. 2 complete sets for Britannia, 2 complete sets for another historical 18-footer, the Mistake, mast and spars for Windward, 3 previous yachts for myself, and the mast and boom for another Ranger class yacht, Cherub, when they converted back to gaff-rigged. The smallest were 7-foot dinghy spars. The largest was a new section of a signal mast that was about 10 inches or 250 millimetres in diameter. I love making spars, and I'm not alone. The senior shipwright at any yard would generally collar the spar-making jobs for himself. One of my pet hates on YouTube is people trying to teach something that they only learned how to do last week. But hopefully I've convinced you that I know what I'm talking about, so I better get on with it. First, you have to select your timber. These days, this is usually Douglas fir, Pseudotsuga menzisii, known as Oregon pine in Australia. But if you can get it, Sitka spruce, Picea sittensis, is a bit lighter. European spar builders mostly used Pinus sylvestris, known in Britain as Scots pine or Baltic pine, the better grades of which were marketed under the name Riga spruce, and some of this was imported into Australia over a century ago. New Zealand kauri pine, Agathis australis, was used in the 19th century, and Queensland and New South Wales builders used bunya pine, Oricaria bidwillii, in the early 20th century. Whatever species you choose, it has to have close, straight grain and basically be the best timber you can find. I've mostly used Douglas fir in the past, but I bought several baulks of Sitka spruce for Volunteers, mast and spars. I was able to find it in long lengths of 6 by 3 inch section, 150 millimetres by 75. I like to use the biggest sizes I can find because it's a lot simpler to build a spar from 2 halves. You may find it hard to find anything over 2 inch or 50 millimetres thickness, in which case you'll need to build up your sections for larger spars using one of a variety of methods. Now, the so-called bird's mouth method is popular lately, and you can build a very strong and light spar this way. I did it once. One of Britannia's booms was done this way, but I'll try not to do it again. I simply didn't enjoy it. There's more time involved in the less pleasant aspects of spar making, the machining of timber and the gluing, and less time devoted to the more pleasant aspects, the shaping of the spars. You need a really good machining setup, and I'd only do it if the timber you had was already in long lengths of small dimensions. I simply can't see any point in sawing up good large dimension timber into narrow strips to make a bird's mouth spar when you could have used it in the larger dimensions anyway. But if you choose to do it, you can still end up with a good result. Most 20th century textbooks suggest you put the inside of the tree to the outside of the spar in a hollow spar. I've always done it this way, but Bill Barnett, a greatly respected Sydney boat builder, told me he always aligned the grain the same way as a tree. Now, I haven't broken many spars and neither had Bill, so maybe it doesn't matter. But regardless of what sections you use and which way you turn it, the grain orientation should be opposed to even out the loads in the spar. Particularly in a solid spar, if the grain is aligned the same way, any bend will almost certainly be uneven. You're almost certainly going to have to scarf some timber to get the length you want. Scarfs in spars are always sloped at a 12:1 ratio. If the timber is 2 inches thick, the scarf is 24 inches long. There's lots of ways to cut scarfs. I generally cut clear of the line with a circular saw, then start with a power plane and finish with hand planes. The ideal scarf is dead straight or very slightly hollow, never domed. I've always used epoxy glue on my spars and never had a problem. The secret is to follow the manufacturer's instructions. Stagger your scarfs on each side so that they're not in the same area along the spar. I'd recommend scarfing together each length and then mark on each mating surface for the taper that you want. Taper is plotted out like this. Describe an arc of the maximum diameter, place marks with a compass set to the minimum diameter, then divide the arc of the enclosed section into 4 and divide the base into 4. Then join these points with straight lines and they are the diameter at 4 equally spaced positions. Plot these out on the mating surfaces of the spar and then cut and plane to the line. Make sure both sides are the same, generally by clamping the pieces together for the final planing. For hollow masts and spars, a wall thickness of 20% has been the standard for some time. A 5-inch mast will have 1-inch thick walls, sometimes thinner for spars. Many gaff masts were not hollow at all, but builders of masts for 18-footers started using hollow masts about the turn of the 20th century. Bill Barnett was building hollow masts with about 17% wall thickness in the 1940s. When Bermudan rigs came in the early 1950s, so-called banana masts were being built with even thinner walls, but they began to break. I chose 25% wall thickness for my mast, 20% for the boom, and 17.5% for the gaff, but I went to 15% for the spinnaker pole. You start cutting the hollow with a series of circular saw cuts of incremental depth and width of fence setting. Plot out sections at regular stations along the spar to work out your depths and fence settings, and take particular care to remember the taper of the spar. Most cuts of a particular depth and fence setting will only be possible between certain stations. There will naturally be shallower cuts and narrower fence settings towards the thinner ends of the spar. I like to plot out a table of where each setting will go. I've chosen to make this spar solid, 8 inches from each end. That allows for the end fitting to be through fastened. Then I'm going to taper the end of the groove of the hollow on a further 6 inches. So this is 14 inches from the end. And so that will taper. You never want the hollow to end suddenly. Quite often I've seen old spars that have just ended them. If they've done it on a router table or a spindle moulder, they may leave them just round like that. I tend to like to taper it off so that it sort of spreads any loading there. You don't have a sharp loading. You certainly don't end it in a square because that would probably just break there and there. I've chosen to make this spar hollow all the way through, seeing it's a spinnaker pole. But some other spars, particularly masts, will have other solid sections, particularly, say, in the way of the spreaders on a mast and in the way of the boom gooseneck. Well, normally you'll have it from a tapering from above the gooseneck, it'll be solid down to the heel of the mast. With my mast, you'll notice that I put wiring for lights and a radio aerial in plastic conduit in the hollow, with a tight channel cut into the solid sections, and I stuck the conduit with polyurethane to the wall of the hollow sections. You may also consider a continuous drain hole for the mast. I know of 2 masts that recently had to be replaced because fresh water had entered through mast fittings and had rotted on the inside. Mind you, this was after 20 or so years. Make sure you really seal any penetrations of fittings or cables so water can't enter. And where cables do exit, angle the hole down. You could also use a router for your incremental cuts, but I generally just use the circular saw and then chisel and gouge out the waste. And a big shout out to Mary Montague for the beautiful gouges. Whatever way you do it, you clean up with a round-soled plane. When I did the gaff, I borrowed a core box plane, which was a bit of fun, but I still used a round-soled plane for final cleanup. Check the depth of the hollow regularly to ensure the correct wall thickness. I always finish off with a good hand sanding and then vacuum up the dust and brush some epoxy into the hollow. Once that's dry, I scoured up the mating surfaces of each half, then did a dry assembly to check that everything was okay, especially being careful to line up the centre line with a laser level. Then I applied thickened epoxy and clamped the halves together. Next day I cleaned up the glue dabs, plotted out the taper on each side, then cut and planed the spar. At any point along the spar at this time, the section is square. Once you're sure this is right, mark the spar for bringing it down to 8 sides. On any but the smallest spars, this is best done with a circular saw with the blade at 45 degrees. Don't throw away the offcuts, they're invaluable when you need to lay out a bunch of small parts for varnishing. Plane down to the lines with power plane and then hand plane. At any point along the spar, each of the 8 sides should be the same width, making a perfect octagon. You need to sight along the spar as well to make sure there are no wobbles in the taper. From then on, it's a matter of knocking off those corners to make the spar 16-sided, and pencil shading is a great way to help gauge an even width to each of the 16 sides at any point. You're not removing much material here, so hand planes are best. When I built the boom and gaff, I'd borrowed a couple of radius spar planes, which helped get them round, but eventually you've got to smooth out the plane marks by sanding. I'll show you the foam block I used for this shortly on another item, but on the spinnaker pole I didn't film the block sanding. Now here's a great tool that I've used a lot for the last 15 years or so. It's a Festo brand, it's an inline sander, and these bases can be moulded to the shape you want. So I've moulded several to different radii for doing mast work. Now Festo have discontinued this line, and I think I know why. They keep breaking down. I've had this repaired 3 times over about 15 years, mind. But there's nothing else like it for doing the job, but unfortunately you can't buy them anymore. You can actually buy inline sanders or inline, what do they call them, pneumatic files that they use in the panel beating game. Air driven, so if you've got a compressor, that's the way to go. They're longer, which actually helps. You're on your own about having a moulded base though. You'd have to work that up somehow yourself out of foam and connect it to the inline sander. If I was still doing masts regularly in the trade, I would definitely get an inline sander for this job. I start with 80 grit paper and work down through 120 grit and 150 grit. If you don't have an inline power sander, you can still work down through the grades with your foam block. Spend enough time with each grit to ensure you remove earlier scratch marks, particularly from the initial 60 grit and the diagonal sanding. Hatching the surface with a pencil helps keep track of your progress. Now the scratches always show up the most on the flat grain areas. That's when you get this sort of pattern in a timber like spruce here or Douglas fir, Oregon pine. And especially where the late wood, the darker wood, is quite thick because of the way that the timber was cut. Those areas there, that the wood's slightly harder there and tends to show the scratches up. Now mind you, you can get too particular. This is, after all, a spinnaker pole. It's going to be dropped, it's going to be dinged, it's going to be flogged, it's going to get rope burns, so it's going to look like shit by the end of the season. So there's a point where you probably don't need to worry about a few scratches in the grain. I polished the spinnaker pole end castings, then fitted their moving parts, then dry fitted them. Then bedded and fastened them permanently, and then varnished the pole. The early coats were applied with the pole on the bench, but I suspended it for the final few coats to keep a better wet edge. Good lighting is essential for this job. Back to the first coat for a moment. It's always best to allow an extra day for finishing, because often your first coat will show up scratch marks from earlier sanding that you can't live with, and you have to sand that whole coat off and start again. The bowsprit on Volunteer is made from the top end of the original mast of the larger Ranger type design Maluka that Sean Langman has done some pretty amazing trips in. It was larger in section than it needed to be, which was just as well because the surface was quite weathered, so I reduced it by flattening top and bottom to the new dimensions. The underside is dead straight, the top and sides are slightly tapered. I then planed the sides, then planed the corners to make it 8-sided, then reduced it just like any other spar through 16 sides, 32 sides, etc., then sanding. I dry fitted the end cap before drilling and polishing it. The spreaders are short lengths of spruce with a sort of foil section, and I used Sparmaking techniques here to take it from a series of flats to the final rounded shape. Now's a good time to talk about this method of sanding a spar. It does work well in removing ridges, but you've got to be careful about the edge digging in and leaving deep scratches that are hard to remove. This is even more the case if you use a method I've seen recommended to turn a belt sanding belt inside out and powering it up on a drum driven by a power drill. Unless you're extremely talented and careful, you'll end up with serious scratches across the grain, which will take more longitudinal sanding to remove than you would have done anyway. I inevitably do most of the early sanding on all spars with shaped foam blocks and 60 grit paper. It's quicker to use the flat side first, but make sure you roll it around the spar and keep it moving. Don't stay too long in one spot. Finish off with longitudinal sanding with the hollow side of the block. I used the same techniques to shape the tiller. Planes and spoke shaves made it 8-sided, then 16-sided and so on. Then the foam block and 60 grit paper, using the flat side first, then finishing off with the hollow side. Then I worked down through the grades of paper with the inline sander, 80 grit, 120 grit and 150 grit. The varnish really brings out the fiddleback grain in this beautiful piece of spotted gum. We're getting real close to launching Volunteer, and I don't know what the next video will be about because there's a whole range of small jobs to complete. But there will be more videos, so thanks for watching, and we'll see you then. And don't forget to check out my books on www.sydneywoodenboatschool.com.au.